Hello friends, welcome to my channel Eccentric Learning. I hope you have gone through the first two parts of inequalities where I have covered the basics of inequalities and how we can solve questions on inequalities with modular sign. In case if you haven't gone through those videos till now, the link has been given in the description box. Please go through it. Also, if you like my videos, then do subscribe my channel and also share with your friends. In today's video, we are going to see quadratic inequalities and inequalities of higher order curves. So let us start with today's video. Suppose if we have a quadratic equation as x square minus 5x plus 6 is equal to 0. So that means there are two values of x for which this quadratic equation would be equal to 0. And we have seen in the quadratic equation video how we can find those two values, that is the two roots. Simply, we can find its factors, which would be in this case x minus 2 times of x minus 3, and this would be equal to 0. So the two roots for this quadratic equation would be simply x equal to 2 or x equal to 3. But instead of this equal sign, this quadratic polynomial could be greater than 0 or less than 0. So that means in that case, we'd be getting some range of values of x for which these inequalities would be satisfied. So let us see how we can find those range of values in such cases. So for the first one, that is if x square minus 5x plus 6 is say greater than 0. And the second one say x square minus 5x plus 6 is less than 0. Again, we can find its factors, which would be x minus 2 and x minus 3. So the product of these two factors has to be greater than 0, which would be possible if this first factor is positive and the second factor is also positive, or if the first factor is negative and the second factor is also negative. So if we consider the first part, that is x minus 2 is greater than 0 and x minus 3 is also greater than 0. In that case, x would be greater than 2 and x would be greater than 3. So x is greater than 2 and x is greater than 3. This simply means that x has to be greater than 3. In a similar way, for the second part, that is x minus 2 less than 0 and x minus 3 less than 0. So this simply indicates that x has to be less than 2 and x has to be less than 3. So if x is less than 2 and x is less than 3, so this simply indicates that x has to be less than 2. So the range of values of x for which this inequality is greater than 0 would be simply x belongs to minus infinity to 2 union 3 to infinity. In a similar way, x square minus 5x plus 6 is less than 0. So in that case, the two factors would be again x minus 2 and x minus 3. Now, the product of these two factors would be less than 0 if x minus 2 is positive and x minus 3 is negative, or x minus 2 is negative and x minus 3 is positive. So again here, if we consider the first case, that is if x minus 2 is greater than 0 and x minus 3 less than 0. In that case, x would be greater than 2 and x should be less than 3. So x is greater than 2 and x is less than 3. So for the first case, the range would be between 2 and 3. In a similar way, if we consider the second case, that is x minus 2 less than 0 and x minus 3 greater than 0. In that case, x would be less than 2 and x should be greater than 3. But x less than 2 and x greater than 3 cannot be true simultaneously. So x minus 2 less than 0 and x minus 3 greater than 0 case is not possible. So the values of x for which x square minus 5x plus 6 is less than 0 would be between 2 and 3. So In this way, we can find the range of values of x such that the quadratic inequality would be greater than 0 or less than 0. But you can see that this method is too much time consuming. So now let us see one easier and shorter way of finding the range of values of x in a much more efficient way. To use that shorter way, we need to know the concept of number line. So we know that a number line ranges from minus infinity to plus infinity, and there is a zero in between. And as we go from left to right, the number keeps on increasing. So here we have say -1, here we have -2, -3, and so on till minus infinity. And here to the right side of 0, we have +1, +2, +3, and so on till plus infinity. So to use this shorter way, what we need to do is simply we need to put the critical points, that is the points at which the quadratic curve attain a value of 0. For this particular case, this quadratic curve x square minus 5x plus 6 is attaining a value 0 at x equal to 2 and at x equal to 3. So let us try to put this point, that is x equal to 2 and x equal to 3, in this number line. So x equal to 2 would be somewhere here and x equal to 3 would be somewhere here. Now we can choose any random point which would be greater than 3 or would be lying between 2 and 3 or would be lesser than 2. Just for the sake of understanding, let us consider a value to be x equal to 5, that is somewhere here. So when x is 5, in that case, x minus 2 would be positive, and x minus 3, that is 5 minus 3, which is plus 2, which is again positive. And the product of a positive and positive number would be positive. So we can say that this curve, that is x square minus 5x plus 6, would attain a positive value when x is greater than 3. So we can simply write positive, which indicates that this curve attains positive value when x is greater than 3. In a similar way, we can consider one value which is less than 2. For the sake of understanding, let us assume x to be 0. So when x is 0, x minus 2 would be 0 minus 2, that is a negative value, and x minus 3 would be 0 minus 3, that is minus 3, which is again a negative value. And negative times of negative would give us a positive value. So we can say that when x is less than 2, this curve attains a positive value. So we can write a positive here, which indicates that this curve attains a positive value when x is less than 2. In a similar way, let us consider one value between 2 and 3. So let us assume the value to be 2.5. So if x is 2.5, in that case 2.5 minus 2 would be a positive value and 2.5 minus 3 would be a negative value. And the product of a positive and a negative value would be negative. So we can say that between 2 and 3, this curve would be attaining a negative value. So from this number line, we can see that any value which is greater than 3, in that case, this curve attains a positive value. Any value which is lesser than plus 2, this curve again attains a positive value. And any value between plus 2 and plus 3, in that case, the curve attains a negative value. In fact, we just have to check on one side of the critical point whether this quadratic inequality is positive or negative. And then we can change the sign alternately, because at the critical points, this quadratic inequality curve will change its sign. That's why to the right side of 3, this quadratic inequality is positive, and between plus 2 and plus 3, this quadratic inequality attains negative value. And again, when x is lesser than 2, this quadratic inequality attains positive value. So the value of x for which this curve would be greater than 0 can be written directly as x belongs to minus infinity to plus 2 union 3 to infinity. And for this curve to be less than 0, in that case, the range of values of x would be between 2 and 3. So you can see how simply by using the concept of number line, we can find the range of values of x in a very efficient way. Let us take one more example to understand this number line method in a better way. Suppose if we have been given a quadratic expression as 2x square plus 5x minus 12, and we need to find the range of values of x for which this quadratic expression is greater than 0 or less than 0. Well, the first thing that we need to do is simply to find its factors. And if we find its factors, the two factors would be simply 2x minus 3 and x plus 4. So now, if we use a number line method, in that case, we need to simply put the critical points. That is the point at which this quadratic expression will attain a value of 0. In this, we can see that the critical points would be minus 4. So let us put somewhere here, and 2x minus 3 to be 0, that is x equal to 3 by 2. So x equal to 3 by 2 would be on the right side of this minus 4. So let us put 3 by 2 to be somewhere here. Now we can take any value to the right side of 3 by 2, that is to the right side of 1.5. Let us assume one point to be 2. So if we assume x to be 2, in that case 2 into 2 minus 3, that is 4 minus 3, would be a positive value, and 2 plus 4, that is 6, which would be again a positive value, and positive times a positive number would give us a positive number. So when x is greater than 3 by 2, in that case this quadratic polynomial would be attaining a positive value. In a similar way, we can check between minus 4 to 3 by 2, this quadratic polynomial would be attaining a negative value, and any value which would be lesser than minus 4, this quadratic polynomial would again attain a positive value. So if x belongs to minus infinity to minus 4 union 3 by 2 to infinity, in that case this quadratic polynomial would be positive. But if x belongs to minus 4 to 3 by 2, in that case this quadratic polynomial will be lesser than 0. So in this way, we can find the range of values of x for which a quadratic polynomial would be greater than or less than 0 simply by using the number line method. Now, the same method can also be applied to find the range of values of x for inequalities of high order polynomials. For example, say if we have been given a polynomial px as x minus 2 times of x plus 3 times of x minus 5 times of x plus 6, and we need to find those values of x for which this polynomial is less than or equal to 0, say. Let us apply the same number line method here. So we'll be drawing a number line first. So this is plus infinity and this is minus infinity. And we'd be plotting all the critical points, that is the points for which this polynomial px would be attaining a value of 0. So in this case, the critical points would be plus 2, minus 3, plus 5 and minus 6. So let us try to plot these points in this number line. So minus 6 would be somewhere here, minus 3 would be somewhere here, plus 2 would be somewhere here, and plus 5 would be somewhere here. Well, make sure that we are plotting the points in a correct order. That is, as we go from left to right, the number is increasing. So that's why minus 6 would be at the extreme left, then minus 3, then plus 2, and then plus 5. Now, let us consider a value which is greater than plus 5. Let us assume x to be 8. So in that case, 8 minus 2 would be positive, 8 plus 3 would be positive, 8 minus 5 would be positive again, and 8 plus 6 would be positive. So the product of all this would be positive. So we can say that if x is greater than plus 5, in that case, px would be positive. In a similar way, if we consider a value between 2 and 5, in that case, px will attain a negative value. In a similar way, between minus 3 to plus 2, it will attain a positive value. Between minus 6 to minus 3, it will attain a negative value. And any value which would be lesser than minus 6, in that case, this px will attain a positive value. Here also, we can see that at every critical points, this curve changes its sign. That is, for values lesser than minus 6, this polynomial attains a positive value. But for values between minus 6 to minus 3, it attains a negative value. and from -3 to 2, it attains a positive value and so on. So that's why we just have to check at only one of the points in the number line, and then we can change the sign alternately at every critical points. So the range of values of x for which px would be less than equal to 0 would be simply x belongs to -6 to -3, and both -6 and -3 would be included, since we also need solution where px is equal to 0, and this would be union to 2 to 5, and again both 2 and 5 would be included. So this is the range of values of x for which px would be less than equal to 0. We can also verify this range of x which is satisfying this particular inequality. For example, between -6 to -3, we can assume a particular value. Let us assume x to be -4. So when x is -4, in that case, x minus 2 would be -6, x plus 3 would be -1, x minus 5 would be -9, and x plus 6 would be +2. And the product of all these four numbers would be a negative number. That is, x equal to -4 would be satisfying this particular inequality. Let us take one more value which is greater than 5. Let us assume x to be, say, 8. So if x is 8, in that case, x minus 2 would be +6, that is a positive number. X plus 3 would be 11, again a positive number. X minus 5 would be 3, which is again a positive number, and x plus 6 would be 14, which is again a positive number. And the product of all these four numbers would be a positive number. So that means x equal to 8 won't be satisfying this inequality. So that's why x equal to 8 is not in this range and is not a solution of px less than equal to 0. So in this way, we can verify our answer whether it's correct or not. Now, let us make a slight variation in this higher order polynomial, and let us raise the powers of these factors to some high number. Let us raise this to the power 3. Let us raise x plus 3 to the power 4. Let us raise x minus 5 to the power 7. And let us raise x plus 6 to the power, say, 11. And we need to find the range of values of x such that this polynomial would be greater than 0. Well, for such kind of cases where the factors are raised to some higher powers, in those cases, we need to check whether the powers are even or odd. Because any even power will always make the factor positive irrespective of the value of x. For example, if x is -4, in that case, x plus 3 would be -4 plus 3, that is -1. But x plus 3 raised to power 4 would be -1 raised to power 4, which would be +1. So because of this even power, all the negative number would be transformed to a positive number. So if we are considering this polynomial, in that case, if x plus 3 is positive or negative, it won't matter as the power here is even. So whether we are getting a positive or a negative number because of some values of x, this even power will make it positive. So when we'll be drawing the number line, in that case, we won't be considering the critical points from such factors. So if we draw the number line and if we plot the critical points, in that case, the points would be +2, +5, and -6. And we are not considering -3 to be one of the critical points in this number line as the power here is even. So if we consider a value which is greater than 5, in that case, all the other three factors would be positive. So px would be a positive quantity. In a similar way, if we consider a value between 2 and 5, px would be negative. And if we consider a value between -6 and 2, px would be positive. And if we consider a value which is lesser than -6, px would be negative again. Here also, we can notice that this polynomial curve changes its sign at the critical points. So the range of values of x for which px would be greater than 0 would be simply x belonging to -6 to 2, excluding both, as at x equal to -6 and 2, px would be 0. And this would be union to 5 to infinity. And again, we are not including 5, as px would be equal to 0 at x equal to 5. So this is the range of x for which px is greater than 0. But if you observe carefully, between -6 to 2, we have a point -3, and at x equal to -3, px is attaining a value of 0. But we need to find those range of values of x for which px is greater than 0. So that's why we need to subtract this x equal to -3 from this range to get the final range of values of x for which px is greater than 0. So in this way, we can find the range of values of x for inequalities of high order polynomials, where we won't be considering the factors which are raised to some even powers, and we'll be considering only those factors which are raised to odd powers, from which we can find the critical points and we can put it on the number line to find the range of values of x which would be satisfying a given inequality. So that's it for today's video, in which we have seen quadratic inequalities and inequalities of higher order curves. And in the next video, we'll be doing some questions based on these concepts. I hope you have learned something in today's video, but if you have any confusion, you can watch the video again, and still if you have any doubts, you can put it in the comment box. I will try to answer each one of your queries. So if you like my videos, then do subscribe my channel and also share with your friends. I'll see you all in my next video. Till then, keep learning, keep sharing, and keep growing. Thank you.